Imagine a world where the sand beneath our feet could store the energy we need to power our lives, reducing our dependence on fossil fuels and moving us closer to a carbon neutral future. A world where our energy needs are met not just by the wind, the sun, or the waters, but by the very earth we tread upon. On today's episode, we delve into this exact world as we explore an innovation that could potentially reshape our energy landscape, the sand battery technology. We're about to turn the sands of time into a more sustainable future. It's time to dive deep, get intrigued, and gather some invaluable sustainability nuggets. Are you ready? Welcome to the Sustainability Nugget podcast. I am Rarasu Maraibi.
And I'm Tosin Faloranjo.
On this podcast, we learn about sustainability by discussing various related topics while focusing on three pillars: the economy, the society, and the environment. Welcome back to the Sustainability Nuggets podcast, everyone. So today we're going to be learning about sand batteries. Yes, you heard me right. Batteries made of sand. And so in order to understand this technology, we have on the board today Dr. Damilola Akamo. He is a thermal energy storage expert and is going to be answering our questions concerning this technology. Welcome, Damilola.
Yeah, thank you so much, Jenny. I really appreciate you for inviting me to this episode of the podcast.
Yeah, we're happy to have you here. So before we jump into sand batteries, please can you give us a brief description about your background?
Thank you, Jenny. My name is Damilola Akamo. I just got my PhD in energy science and engineering from the University of Tennessee.
Our latest doctor.
Yeah. So my PhD focused more on thermal energy storage research, though I was using salt hydrate thermal energy storage as basis of my own PhD. So I believe I can give a good details on sand battery thermal energy storage. So my master's was also in material science and engineering from University of Tennessee, Knoxville. I had my first degree in mechanical engineering from Obafemi Awolowo University. So over the years, I've been able to explore different or diverse areas of engineering, and my PhD is more of an interdisciplinary program, which involves material science, it involves chemistry, it involves mechanical engineering, and what have you. So I believe that I have that strong interdisciplinary background and perspective.
Yeah, definitely. So I'll just like to point out that this is even your second time on this channel. Of when you came to the channel, though it was not yet officially a podcast, but I'm definitely going to like the episode we had previously. It's just wonderful to see how we've grown over the years, right? That you were in the middle of your research, now you're a doctor. So definitely it will be linked down in the description. So let's jump right into sand batteries. Can you start by explaining what sand batteries are and how they work?
Okay, so basically when we say battery, we are trying to store energy, right? The usual battery we see everywhere, these are chemical batteries. They are storing electrochemical energy, right? So now sand battery is just a form of a thermal battery that stores heat energy or thermal energy using sand. Before you can store energy, you need a medium, right? So in maybe lead acid battery, we know we have the electrode, we have the various acids that helps to store those electrochemical energy. But in our case, in sand energy, we are using sand as the storage medium. So we use sand to store heat, we use it to store thermal energy. And one of the ways in which this concept operates is such that we've been talking about renewable energy every now and then. That is the hottest topic out there. We want to solve climate change problem. We want to preserve our environment. We want to preserve our climate from greenhouse gas emission. And we are shifting towards renewable energy in form of solar energy or wind or hydro, right? But these forms of energy are actually intermittent. What do I mean by that? They vary from season to season. Summertime, we have a lot of sun. Winter time, the sun is not there again, right? You need to find a way to solve this intermittency problem in renewable energy technology. So one way in which we've been trying to do that is to maximize energy storage, right? So you need to find various energy storage solutions. And one approach that they are using currently, I mean, one of the newest form of energy storage solution is actually the sand battery, in which you take the excess electricity from, say, the solar panel or from the wind turbines, and then you convert that to heat.
Oh,
You
okay.
pass it through. So you convert it to heat and pass it through pipes or heat exchangers to heat up the sand. And then the sand can store this thermal energy for longer period. So in the thermal battery, you have a container, I call it a tank. It's always very gigantic, very big.
Yeah.
We have the tank. Then you have very effective insulation system within the tank to prevent the heat, loss. And then you have, massive amount of sand in the tank. You also have circulatory pipes and heat exchangers to help you pass the heat into the sand to be stored for maybe for months. And then when you need it, you just pass cold air into the pipe, into the circulatory pipe, so that there can be heat transfer. We know based on the law of heat transfer, temperature heat will always try to move from the point of higher temperature to a point of lower temperature. So that's basically how you're able to release that heat. And the good thing with thermal batteries is that they are used for high temperature applications, because the melting point of sand is around maybe 1,500 to 1,006, around that range. So the sand can be kept at temperature between 500 to 1,000, so you use them to heat your home, you use them to heat water, water systems, and you can even use them in industrial processes.
Okay. So when you were saying, you talked about electricity being converted. So basically electricity from any source. So is the source of the electricity that makes the sand battery renewable or not? Like, because if it's from...
Yes, we try to, as I said, during the summertime, solar energy is being produced massively, and it even gets wasted because there's an amount you can produce that, okay, this is enough for me, and the rest is going to waste. So we don't want this wastage. We are trying to achieve sustainability, right? So one way in which we try to prevent this wastage is to see, okay, why can't we just take that thermal energy, and store that thermal energy for use? So if it is not useful again during the summertime, it can be useful during the winter time. Right. So the way we do it is to store the heat, from the renewable energy sources. And one of the main thermal battery setup that we've seen, they even connect it to the grid, the electric grid, such that when the solar energy is actually being produced and is even getting to wastage, they can just quickly bypass it to the thermal battery. So they try to pass in the electricity at the cheapest amount. You also want to consider the cost too.
Yeah, exactly. So before we go further, how did this concept of sand batteries even come about? And like, has it been something that has been on for years, or is it recent? What was the inspiration?
Yeah, I would say thermal energy storage has been on for years, right? It's a concept that has been there for years, where you try to heat up a medium, store energy, and then you use during the later time. But the thing is, we really depended on gas as a means to maybe utilize, to heat the homes, to do a lot of industrial processes. But the dynamics is changing now. Why? Look at the current war that is ongoing in Ukraine, for instance.
Yeah.
The gas prices are on the high. Like, it's it's so high. I mean, the gases are not really so readily available like they used to be. There is a sanction on Russia. They can't export their gases to other countries. Finland, for instance, Finland has joined I mean, yeah, so they are also part of this whole NATO stuff, and they can't even get gas from
Yeah.
Russia, right? So they need to think about what next to do to get to eat their homes, to get to eat their offices, to get to provide heat needed for industrial processes. So I feel, all these international politics and all, is affecting the dynamics and is making us think outside the box, to consider alternatives that can help our environment in quote, and can also aid our survival. So it's more like a relatively new concept, to use the sand to.
Yeah. So basically for the fight for energy independence. So I'd like to say something like when I think I heard of sand batteries last year, maybe mid last year or late last year. And like I was like, do you know like what took me back? I remember that okay, sand is actually like silica dioxide. Yes, it's a like I didn't think about it before. But like, do you know what I remembered? Back in Nigeria, like when I was little, my mother bakes a lot. And like I remember that like when there was no electricity, like when we could not use the oven, my mother used sand like in a big pot, like to bake cake and so I was like, wow, this concept has been used.
Yeah, I mean,
yeah, but like now I like designing it, like so it's just it's interesting when you see like some innovations or some concepts that like will be able to solve like world problems.
Yeah,
I actually got it from like if you think back to traditional things, like so it was quite interesting to like see that link up. That wow, my mother was using sand to actually.
Yeah, I mean, she was already utilizing sand battery.
Yes, exactly.
Yeah.
So moving forward, like, so can you explain the efficiency like in sand battery? Because we talked about like using electricity to convert heat. Like when we think about first of all, even like gas turbine, like for electricity is just about like 35% efficiency. Like the rest is lost as heat. So now thinking that we're now like sending electricity to it to be stored, then to be sent back to, like what is the efficiency like?
I mean, you've really raised a valid question, I must say, because that's a major problem with the sand battery or with turbines, as you said. Right now, we've seen efficiency between 20 to 25%, meaning that when I put in 100, I can only get between 20 to 25. So that is still very low, it's very low. But when we consider the amount that is even being wasted, right, you still want to try as much as possible to save. If I can save 20 to 25% out of 100, I mean, it's still reasonable, and we can also use we can save this for months. Don't forget, like for months, so that if I save it during the summertime, I can get to use it during the winter time.
Okay.
To eat the space, to when there's no sun per se. So you need a lot of heat during the winter.
So that's another question. Like when you're saying get out, are you saying get out like get out from the sand battery to be used in thermal applications, or can this heat be stored, be reconverted to electricity, or it doesn't make sense again to reconvert?
Thank you for that question. So now currently what they are doing is to just store and then convert to heat, I mean, for thermal applications. They're using it to heat homes for industrial processes. But there is a theoretical estimation that says that you can even use it to, drive turbines to provide energy, more like steam turbine. So that's I feel that's one of the next steps that sand battery is actually going to get to, where we can use these things to also generate energy back, when you have steam, the steam can turn the turbine and we can generate electricity. But I don't think we are there yet. We are just still, trying to use it to heat up our homes,
Which is also
run.
very important, because if you look at the emissions distribution, I can't tell you the exact value now. Eating actually collects a lot.
Yeah.
So if that demand can be met, that's a
Yeah,
large.
it's a massive one actually,
Mhm.
because eating the building, I mean, I think it took about 40% of the
Oh,
emission,
yeah.
global emission. So if you can take that away,
Mhm.
that's a massive chunk, and that's one of the good reason why we have to even adopt sand battery, because the emission rate is insignificant or or not even there.
Yeah.
So, and that's the kind of technology we want to adopt, so we can meet the net zero
The
goal for
goals.
2050.
Yeah. So coming here, like, what really is the advantage of this sand battery over other batteries like lithium ion battery, for example, or the pumped hydro storage?
Yeah, I mean, every of these energy storage solutions you mentioned have their own advantages, they have their own disadvantages. Look at lithium ion battery, for instance. It is widely used, right? People have adopted it. It's something that everyone is actually using. Even hydro, we know that hydro too can give us energy and it's also renewable. But with sand battery, one, it is relatively inexpensive because you have sand as your storage medium. It
Mhm.
is readily available. You don't have to fight any war to get it. So it is relatively abundant. Let me put it that way.
Okay.
And it's actually, I would say, it is relatively inexpensive to build too, because you just need sand, you need a tank,
And,
and then you need your heat exchangers
and
and pipes,
insulation.
which can be made with inexpensive materials. And one good thing about sand batteries is that they have a very long lifespan, between 20 to 30 years. So it's
Okay.
estimated that they can last between 20 to 30 years compared to lithium ion battery, for instance.
Mm.
So lithium ion battery has high efficiency. It's readily available. I mean, used every, but the lifespan is actually, short, right? And another good thing about sand batteries is that they don't produce emission or
Mm.
insignificant emission. So those are the kind of things that I want to look at. Then for pump hydro, they also consume a lot of land,
Yeah.
So,
But
but the good thing about
sand
sand,
battery. Okay.
I'm going there. So the good thing about sand battery is that they are also exploring underground, more like creating underground storage
Mm.
rather than building it just
Oh, makes sense.
on the land. So that way we can also conserve the land. So
Mm.
those are the pros and cons that we have to consider.
Yeah.
I mean, for the fact that it has low or no emissions,
Yeah.
it has long
That's a
lifespan,
major.
20 to 30 years. I mean, those are things that
Yeah.
that
The
you want to
number waste,
consider.
like end of life waste, like the sand, right? Is not toxic, so you can just
No,
report.
it's not toxic. You can use the sand for other applications.
Yeah.
Even the metals and coal, you can also recycle them and use them
Yeah.
for other
I think that's
applications.
a major
Yeah.
advantage too. When you said a lifespan is like 25 years, I'm wondering, like, what happens, like what part of the battery is actually dying? Is it the sand that is losing its thermal properties, or is it like the tank and all that is eroding? Because like I'm also,
Yeah. Yeah. Every other thing we actually contribute at the end of the day.
yeah.
The sand too cannot just when you
Continue.
use something over and over and over again, the
Mhm.
point is going to actually wear out. Even the equipment you're using, the pipes and all, you have to, at some point, decommission and, replace those set of components just because of the time span you've used them. Yeah.
Okay.
So even the sand, you have to check them to be sure that, everything is actually in good condition, that they're able to absorb the heat and
Yeah.
retain them long enough.
And so that comes to another question. Is there a particular type of sand that is used for sand battery? Because we have different types of sand, right? We have white sand.
Yeah, they usually call this one, they usually call it the builder sand, just
See what?
builder sand,
Builder
builders.
sand.
Yes,
Okay. So
like what they use in building, basically.
like what white sand, right? The one you
Yeah,
find
kind
in
of.
the beach.
Yeah, I mean, yeah, you can use that too.
Okay.
So far it meets the necessary criteria you need. So
Okay.
I mean, that's even the one of the ones that are readily available, you know.
Yeah.
Yeah,
Yeah.
so
So, but what are the biggest challenges? Because now we're talking about sand battery. How come everybody's not using it? Like, what is the challenges that is affecting this wider like adoption in the world?
yeah, a lot of challenges. One, I would say that right now, as I said, the the technology is relatively new. The first one that we've seen so far was built in Finland.
Okay.
And as I said, it came about mid last year. You're
Mm.
very correct. I think it was around June 2022 that they built that first one. And before you can really say that, oh, everybody just starts using it, scalability,
Mm.
I don't think it's already up to scale. I mean, to meet the global need or global demands like lithium ion batteries.
Mm.
So that one is a major challenge. Then another thing is regulations. The kind of regulations, energy regulations that we put in place for the other well-established energy storage systems or solutions are not yet in place for sand batteries. So that aspect too is also limiting its widespread adoption. You know, when there are regulations that are set in place, I believe that sand batteries are actually going to get a wider attention. Then you also want to think about costs too.
Mm.
To
Yeah.
build that kind of tank. I don't know if you've seen
Yeah. So I've
the,
seen the
the,
polar night
the
energy. Is that the one you're talking about?
yeah,
Yeah.
exactly.
It's
Yeah,
really
yeah.
big.
No,
Yeah.
yeah. So those are also part of the things I want to consider. The materials they are using. Another thing is efficiency that we talked about.
Mm-hmm.
You
Yeah.
know,
Yeah.
when you are producing 20 to 25%, when others can produce more than that, you also want to think about the efficiency. But I believe that if you are able to maybe improve on our design of materials,
Okay.
it might also help, conserve more energy and increase the efficiency of
Okay.
energy transfer
Okay.
along the line. Yeah.
Yeah, I know that you've spoken about how like the environmental footprint is really small, but like, can you just speak a little bit about the life cycle? I know it's relatively new, so it's quite hard to really tell like the challenges along the way, but with your like expertise in thermal energy storage, what do you think like the life cycle of the sand battery would be like?
For me, I think when we compare it to lithium ion batteries, I would say that the life cycle for some batteries will still be better because if you look at it as for lithium ion batteries, to even get the lithium in the first place
Mm.
is one, you have to mine. It imposes a lot of environmental challenges on us, pollutions, here and there, the cost to even mine. Lithium is not really readily available. Like for instance, I do some salt hydrate analysis. I mean, some salt hydrate experiment, and I try as much as possible to run away from any salt hydrate that has lithium
Mm.
because I am not sure that kind of material will be readily available. You understand?
Yeah.
So that also cuts across, our comparison now that getting lithium is a tough one. But for sand, when you look at the construction, from the construction to the storage, from storage to release, from release to maintenance, and then from maintenance to the end of life, I don't really think there's a lot of maybe energy, environmental footprint along the line. The main thing is that I want to look at the construction. What are the kind of materials we want to use? And I believe that there are a lot of environmentally benign materials that we can use and materials that are recyclable
Mm.
along the line. So I would think that you know the life cycle will not really impose a lot of environmental
Yeah.
footprint,
Yeah.
unlike lithium-ion batteries.
So to confirm, the only one you know right now, like that's been applied, is the polar night energy one, right? Or do
Yeah,
you
yeah,
know
the
of other
polar,
companies?
the polar night energy, the one in
Yeah,
Finland. So
yeah.
that was
Do
good
you
at
have any
2022.
idea of like the costs? Like,
I don't have idea of the cost right now. I
okay,
mean, I couldn't really lay my hands on the
yeah.
installation cost. I was only able to see the power requirement and all that. It gives out about 100 kilowatts of power.
Okay.
They've used it to power homes. I think they're able to use it to power 900 homes in one day.
Wow. Nice.
So, that's a very good one.
Yeah.
You can do that. Then there's also another company in Australia, because Australia too has been doing a lot
Okay.
in terms of feasibility studies on adopting sand battery or sand thermal energy storage solutions. Based on their analysis, they saw that sand battery can actually help them reduce emission by 16%.
Nice.
Like when they
Wait,
replace
sorry,
it
I'm
with
like,
gas.
this can be like I don't know, random, not good question, but like, is Australia usually cold too? Do they have like the winter period?
Oh, no,
Okay.
no. So they were doing the analysis based on industrial processes. They use gas. They use gas a lot for industrial processes. So they also have the same challenge that when the war started, they didn't want to sell gas domestically again. They want to start exporting it, so they get more money. So gas prices is also on the high. It's on the high in Australia. So they thought about, okay, what if we replace the gas for industrial process with sand storage system? And they were able to see that, we might be able to reduce our emission by 16%. So there's a company right now, I think they call it 1414 degrees. So they are using melted silicon rather than sand. I mean, still similar, similar technology to store it and then release it when it is needed. So those are the two companies that I've seen that are basically doing something very similar, regarding sand thermal energy storage. Yeah, polar night energy and 1414 degrees in Australia.
Awesome. So to conclude, what do you see as the future for sand battery? Do you think it will really be adopted worldwide? And in what applications? Like, what really do you see, and what improvements can be made?
Yeah, I'm the type that is very optimistic. And the part that is even thermal energy storage, it's an area that I've also betted on. That we'll see major improvements. I believe that over time, the sand battery will actually be adopted. I know that the CEO of, I think, the Polar Night or the Australian company was saying that they plan to install about 10 more sand battery system, 10 more units, by next year. That's a good one. A lot of companies are also trying to, invest in this kind of technologies. And I feel that Asia will take a very good chunk of the market. North America too, we do. Yeah, so I believe that there's going to be widespread deployment of sand batteries. And in terms of the science or the research side of things, I also foresee that we'll be able to improve the efficiency of these systems using capable or effective materials that can help us store and release the energy efficiently. Another thing that I also foresee is that I believe that we'll be able to, generate energy, using this heat from the sand battery. It will be able to drive turbines and generate energy, electricity, as the case may be.
Yeah, I knew this was the last question, but you mentioned something about like improving the material. So does that mean like maybe treating the sand to hold more energy, or are you talking about the container, or is it everything?
Yeah, it could be everything. When it comes to material, it could be maybe we want to treat the sand with some chemicals that can help us, hold on to it. It could mean that we want to even use more effective metals for our pipes, for our heat exchanger. It might mean that we want to design our heat exchanger to conserve or retain more energy and even help in transfer of energy. So I feel that it cuts across everywhere. Then even the maintenance too, maybe we might be able to get more effective with the maintenance of the system that will improve the lifespan of our system. So those are the things that I foresee. We've basically spent maybe 1 year, based on the first one that just came out from Finland. I would think that we will surely see improvement. If Finland is betting on it, I mean, the Nordic countries, other Nordic countries too might want to adopt it, because all you need is to supply electricity, cheap electricity, from solar or wind, store it for months. The fact that I can even store it for months shows that this thing is very effective for seasonal storage.
Yeah.
So those are the things that make me feel that we'll see widespread adoption of this technology.
Awesome. Thank you very much, Dr. Dami.
Yeah.
For really helping us understand this technology more. Thank you for the audience for watching till the end. I'm going to be leaving Dami's contact in the description box in case you need to contact him. And remember to subscribe to the channel, follow us wherever you listen to your podcast, YouTube, Spotify, Apple, wherever. And we'll see you on our next episode. Bye.
Thank you.
Yeah.
Thank you. Yeah.
Thanks so much for listening to the Sustainability Nuggets podcast. I am Rarsu Maribi.
And I am Tosin Folarunshaw. If you enjoy this podcast, please leave a rating and review on wherever you listen to your podcast.
You can also show your support by signing up for a small donation to help sustain future episodes. You can find all relevant links in the description. See you in our next episode.